All right, so this is number 59 out of chapter 3.1 in the book, page 101. Reading through the problem, it says that the total revenue are in thousands of dollars. That's an important piece that we'll need later. Earned from manufacturing and selling handheld video games is given by this particular function, where P is the price per unit in dollars, and R is revenue, okay, and P is the price per unit. Okay. Now, finding the revenue when the price per unit is $20, $25, and $30, I said here that I knew the price is just P. Well, then I can just say, well, for the first one, R of 20 is equal to negative 25 times 20 squared plus 1200 times 20. And we're just replacing P with the input that I have here. And I'm not going to go through the exact steps of solving that one, but what you end up getting is you actually end up getting 14,000. But keep in mind that the revenue is meant to be in thousands of dollars. So 14,000 thousandths, well, 1,000 has 3 zeros on it. So in fact, you would just add 3 additional zeros to this if you wanted to put it into dollars, and it works out to 14 million. Okay, and basically what you did was you took 14,000 and multiplied it by 1,000. Now, finding the unit price that will yield the maximum revenue, this part's definitely a bit more challenging, but let's keep in mind, let's go ahead and make a quick sketch of the graph here. And I would assume that being a profitable business, it would most likely exist mostly above the x-axis, but the sketch itself isn't going to be that important. It's just going to be so I understand what I'm actually looking for. Now, if this here is the revenue, okay, depending on the price per unit, well, then in reality, what I'm really looking for, okay, is I can see here that my original equation is a parabola, and it's going to be opening downward since it has that negative leading coefficient. So I'm really looking for the relative maximum, or the vertex. And in fact, this is just the maximum of a parabola. Okay, but I'm trying to find the vertex. Well, we've seen before that the best way to find the vertex is to go ahead and put it into standard form. So we have R of P is equal to negative 25P squared plus 1200P. I'm going to go ahead and move up so I don't end up off the paper. Now, to put this into standard form, first we're going to make sure that our P squared has a 1 as a leading coefficient. So I'm going to factor out that negative 25 P squared plus 1200P. Now I'm also going to go ahead and take one step ahead here and know that I'm going to be putting an additional number here so that I can make this a perfect square, and if I add it here, I'm going to have to subtract that same number right out here. Now there is a formula for it, but I'm getting in the habit of simply rewriting this like this, in that I know that the first term here is going to be a P times a P. And I made a mistake here. When I factored out the negative, I should have made this negative as well. Okay, you factor the negative 25 out of the 1200, and this 1200 should no longer be a 1200. It should be a 576. I apologize for that. Okay, but that was simply from the factoring out the greatest common factor here. And again, you should always double check to make sure that you are in good shape. And I did that wrong again. That's not supposed to be 576. It is 48p. There we go. All right, now I can see here that I'm going to have a minus since this is a negative. Okay, and then I'm looking for some number plus itself in the end, because if we do outside and then inside, it's going to be this times this plus this times this. Well, that number in fact is going to be 24. Okay, negative 24p plus negative 24p will get me negative 48. So kind of working backwards, negative 24 times negative 24 should give me this last term, and that was that 576 that I put up there earlier. Now, some of you are thinking, well, now I need to subtract 576 from the outside, but we can't forget that in fact we're not really adding 576. We already factored out a negative 25, so the number that goes out here in reality needs to be negative 25 times 576, which is none other than negative 14,400. Okay. So kind of combining some things together, just bringing this down here, I see that a negative and negative is going to give me positive 14,400. Okay. And then I know that this, in fact, is none other than P minus 24 quantity squared. I have the negative 25 out in front, plus 14,400. Okay. Right? And now I have this in standard form, so I know that my vertex is located at 24. And this shifts 24 units to the right, okay, from the origin, from the parent function, and then it goes up 14,400, except I do know that R of P is in thousands of dollars, so I need to multiply this by 1,000 to get my true graph. Well, actually, for the vertex in the graph, I should leave it like this. I'm getting ahead of myself. That's going to be the answer to a coming up problem. Now, they want to know find the unit price that will yield the maximum revenue. Well, the unit price is described by the x-axis, by our inputs, meaning that $24, when P is equal to $24, that is when I will get the max revenue. Now, if you move on to C, we've actually already found the answer to C. C asks for what the maximum revenue would be. So this one actually yields max revenue. Well, max revenue is given to us by the y-axis. So when we're looking at this, really we are just looking for how high is our vertex. Well, our vertex is at 14,400. And this is what I was saying before, that this is 14,400 thousands of dollars. So to get the actual revenue, okay, and really what we're getting is R of 24. Okay, we need to multiply this by 1,000. Okay, that's just getting our units straight. So 14,400 1,000s is just 14,400,000. Okay. And D is an explanation. It simply means that you should be able to walk someone else through your process for this particular problem. Again, this is actually a fairly realistic application of when you would see a parabola used in the real world. Thanks so much.